Hey geometries, guess what? This is lesson 8-2, day 1, and this is Mr. Bloom. Okay, so I got to get my arrow up here, got to have direction. And lesson 8-2, special right triangles. There are special friends. Okay, our objective today, students will be able to use the properties of special right triangles. Today, boys and girls, we will work with a special right triangle that is called a 45-45-90 triangle. So let's going on. What's next? Oh, look at this. We have our opening. Oh, we got another arrow here. Okay, we got to bring that up so we can talk about it. Theorem 8-5, 45-45-90 triangle theorem. In a 45-45-90 triangle, both legs are congruent. Both legs are congruent. They're the same value. You know, we're not going to use S because, boy, you know, when I write them, they look like fives. So we're going to call them X. And we're going to call it X. And this is X, the square root of 2. So now we're looking at this, and both legs are congruent, and the length of the hypotenuse is the square root of 2 times the length of the leg, or a leg. So the hypotenuse is equal to the square root of 2 times the leg. Hypotenuse is the square root of 2 times the leg. So now let's use this. Find the missing side lengths of the triangles. So if we're going to find the missing side lengths, and we know the pattern, and we know that in a 45-45, that's base angles are congruent, and the base angles are congruent, the sides opposite them have to be the same. So this is 11. And we just learned that this is 11, the square root of 2. But remember, we've been working with Pythagorean theorem, and if I go 11 squared plus 11 squared is equal to c squared, this becomes 121 plus 121 is equal to c squared. This ends up being 242 equals c if I take the square root. But now keep in mind, we added two 121s to get there. So this really becomes the square root of 121 times the square root of 2. And that's where 11, the square root of 2, comes from. So instead of doing all this, we know the pattern is x, x, and x, the square root of 2. Okay, and that's how we do these. So instead of doing Pythagorean theorem, use the pattern. So this next one, 6, the square root of 2, and now you're on for the last one. Find all the sides. Okay, so you've got 9, 9, and 9, the square root of 2. Now, your next thing is to continue using the pattern when you're provided the hypotenuse. Okay, so now we have the fact that we have a hypotenuse that is in terms of the square root of 2. So what are the legs? Okay, so check out the legs. So one leg is 9, and the other leg, because they're identical, has to be 9. So turn me off and do the next one. Okay, so now what you've got here is a hypotenuse 10 the square root of 2. My legs are 10 and 10 according to our pattern. And I got 12 the square root of 2 is my hypotenuse, so I got 12 and 12 are my legs. Okay, I hope this is going well for you. Now, my last three are different because I'm just going to back up a second. And what I did for the hypotenuse, remember, I took my leg value and divided and multiplied by the square root of 2, and I got 12 the square root of 2. If I divide by the square root of 2 on both sides, I get x is 12, and that's where I'm getting that and that. So if I have the hypotenuse, I divide by the square root of 2. So that's what I'm going to do. If I have the hypotenuse, because the hypotenuse is x to the square root of 2, and I have the hypotenuse, I divide by the square root of 2. Now, I have this as 1, okay, and I have x is equal to 12, the square root of 2. Now, when I do this, you learned last year that I can't have a square root on the bottom. So I have to multiply by a form of 1 that is driven by that square root of 2 on the bottom. Now, this becomes 12, the square root of 2, all over 2. Well, 12, the square root of 2 divided by 2 can still be reduced because 12 is divided by 2 is 6. So this is 6, the square root of 2. So now I've got 6 the square root of 2 and 6 the square root of 2. Now I've got some folks going, oh, wait a minute, Bloom. We are supposed to take that pattern and go, okay, you take x and you multiply by the square root of 2 to get to 12. I go, yep, you take x, you multiply the square root of 2, you get 12. What if x is 6 the square root of 2? Well, 6 the square root of 2 times the square root of 2. Hey, that is 12. No way. That works. Okay, it's your turn. Let's see what you got. Okay, I will make this a little bit smaller, and we'll group that together and we'll get that rolling. Now remember, this is all about us working with the Pythagorean theorem. These patterns wouldn't exist without the Pythagorean theorem, but I'm just making it faster so we can do other things. Remember, x times the square root of 2 is equal to 5. If I divide by the square root of 2, divide by the square root of 2, so I can find what x is. Remember, x are these values. I now find that I have x is equal to 5 over the square root of 2. But I have to multiply by the square root of 2 over the square root of 2. So I get 5 the square root of 2 over 2. Now remember, I got 5 the square root of 2 over 2. Over here, I had 12 the square root of 2 over 2. Okay, right there. Wow, I wonder if that's a pattern. Well, let's see what's going on. Let's do this last one. And I've got, again, x, the square root of 2 is equal to 9. I just did 2. You do this one on your own. Go. Okay, welcome back. We're going to divide by the square root of 2 to get x by itself. X is equal to 9 over the square root of 2. We're going to rationalize the denominator by multiplying by a form of 1 to get rid of the square root on the bottom. When we do that, our final answer is 9. The square root of 2 over 2, no way. 9 the square root of 2 over 2, and 9 the square root of 2 over 2. And this one over here, remember, is 5 the square root of 2 over 2. And this is 5 the square root of 2 over 2. And that is 45, 45, 90 triangle patterns. Okay, now, if you got questions, you should really make sure you talk to your geometry teacher and double check how to do things. So let's use this in something. Finding the distance. Softball. A high school softball diamond is a square. And they just told me that this is a right angle, this is a right angle, this is a right angle that's been cut in half. So this is a 45, 45, 45, 45. Okay. 90 triangles. The distance from base to base is 60 feet. So I know that this is 60, this is 60, and this is 60. How far does a catcher throw the ball from home plate to second base, assuming that they are doing it the shortest distance between plate to plate? Well, what we just saw was 60, okay, and I've got this relationship. This is 60, that's 60, this is 45, 45, this is second, this is home, remember? So this distance is just gonna be, what was that? Oh, that's right, because Bloom told us about this pattern. X, X, X the square root of 2, and this is 45, 45, and that's 90. This must therefore be 60 the square root of 2. How far does a catcher throw the ball? Well, the distance thrown is 60 the square root of 2. Now, if I wanted the closest in feet or anything like that, I'd just go 60 times second square root of 2. And I would be done, 84.85 feet, or about 85 feet. Okay, so I get on here and I go, well, about 85 feet. All right, so I got it exact because I knew the pattern, but I also put it down to see what I'd look up on a tape measure. All right, so there we are, 45, 45, 90s, and that's our assignment. Now keep in mind, if you have questions, you must ask about them. This is a pattern that is used. Make sure you're comfortable. If you have follow-up questions, make sure you seek out enlightenment. I'm Mr. Bloom, and you're not. Have a great day.